Hello, everybody. We're on day 15 out of 50 of our SAT math prep series. And if you've made it along this far from day one, I'm sure you're already in good shape for the August SAT math section. And yeah, today we'll be tackling some more problem solving and data analysis problem types. We're going to dive into our first one over here. So we have the ages of 20 students enrolled in a college class. The table above shows the distribution of ages of the 20 students enrolled in a college class. Which of the following is the correct order of the mean, median, and mode of the ages? So we have to find each of these values, mean, median, mode, and we're going to start with the mode because it's the easiest value to find here. And mode is simply just the most frequently outputted data type. So here we have the frequency table and we have the quantity of each age, or not the quantity of each age, but the age here. This is the quantity over here, and this is just the category of age. So whichever has the highest frequency appearance is our mode. And for this, since we have a frequency of 6 for age 18, this is going to be our mode for this data set. Now, we're going to handle median. And remember, median is the middle number of our data set. So if we have 7 numbers, I'm just going to draw all ones for now. We cross out each from one side until we get our middle value. So when it's even numbers, obviously you're not going to get one number, you're going to get two, and it's the average of the two numbers, but it's the same deal. And with 20, we know that our middle number is going to be 11 or 10 and 11, the average of 10 and 11. So if we look at our frequency table, we need to count from smallest to greatest until we get to 10 or 11. So we have 6 here, and then we have 5 here. So that adds up to 11 already. But as we see, 6, if we start counting from 6, from the 5, we have 7, 8, 9, 10, and 11. So this is going to be our median of 19. I hope that makes sense. It's just the middle number, but since it's an even number, it's the middle two numbers. And if you can't see off the bat that it's 10 and 11, what you can do to solve for what number is going to be the median, not the value of the median, but the number in which the median is going to be found on, you can do, if it's an even number, it's 20 plus 1 divided by 2, which is going to give you 10.5. And that 0.5 indicates that it is between 10 and 11. So you have to average that, those two values. So since 10 is 19 and 11 is 19 respectively, 19 is our median. These numbers are just indicating the number of, not the number of the value, but the number in series, like the 10th value or the 11th value respectively, not the actual numbered value. It's just the series of it. So our median is 19, and we have now the mean. So the mean, we're going to add all of these up. So we have 18 times 6 plus 19 times 5 plus 20 times 4 plus 21 times 2 plus 22 times 1. So it's just 22 plus 23. And then I'm going to add 30 over here because I couldn't fit it over there. And then we add all of these up and we divide by the total number of values. So we have 20 over here because it says it's 20 students. And we're going to put this into our calculator now. and I'm going to get a value of 30 plus 18 times 6 plus 19 times 5 plus 80 plus 21 times 2 plus 22 plus 23, and that's going to give us 400 divided by 20, which is 20. So this is our mean. So if our mean is 20, our median is 19, and our mode is 18, we know that this is going to be our answer. Mode 18, median 19, mean 20. So it's a long kind of ish problem if you're not comfortable with mean, median, and mode, but if you do know it, it should be relatively quick and easy. So looking at this next problem, how many fluid ounces are equivalent to 76 quarts? We have our conversions over here. 8 fluid ounces is equal to 1 cup, and 4 cups is equal to 1 quart. Quickly, I'm going to rewrite these conversions as fractions because that's going to help us when dealing with stoichiometry, which I'm going to show you in just a second. So 8 fluid ounces, 1 cup. This is also equal to 1 cup, 8 fluid ounces. Whatever you need, you could just flip the fraction because it's a ratio. And then 4 cups, 1 quart. Okay, so we have 76 quarts, and we have to convert that to fluid ounces. So we don't have quarts over fluid ounces, but we do have quarts over cups. So we're going to do 1 quart and 4 cups. I'm doing the quart strategically on the bottom, not just because I wrote the first ratio like that, but so they cancel out. And then we have the cups, 1 cup over 8 fluid ounces, and then the cups cancel out. And then you simply just multiply. We have 76 times 4 times 8, and that's going to give you a value of 2,432 fluid ounces. And that's how many fluid ounces are in 76 quarts. That's going to be your answer. You're going to input that into the computer, and yeah. Looking at the next problem. Residents of a town were surveyed to determine whether they are satisfied with the concession stand at the local park. A random sample of 200 residents was selected. All 200 responded, and 87% said they are satisfied. Based on this information, which of the following statements must be true? For our first option, of all the town residents, 87% would say they are satisfied with the concession stand at the local park. Okay. Of all the town residents. Do we know that of all the town residents, exactly 87% would say that, even though we only had a sample of 200? Can we assume that exactly or know that 87% exactly of all the town residents would say they're satisfied based off of a small survey sample? We can't, so that's going to be false. Looking at our next one, if another random sample of 200 residents were surveyed, 87% would say they are satisfied. Since we only conducted this survey one time, will never have enough certainty that we will get the exact same result. Only if it specifically mentions that the margin of error is 0%, then we could say if another study was conducted, we would have the exact same results as the first one. But since this isn't the case, this is also going to be false. And since it's saying which of the following statements are true over here, we take neither. Okay, looking at our next problem, second to last one. A sample of 44th grade students was selected at random from a certain school. The 40 students completed a survey about the morning announcements, and 32 thought the announcements were helpful. Which of the following is the largest population to which the results of the survey can be applied? Okay, the 40 students who were surveyed. Yes, that is true, but the question's asking for the largest population. So for now, that is correct. All fourth grade students at the school. Well, since it's a survey of only fourth grade students from that same certain school, it can be applied, the results of the survey can be applied generally to all fourth graders at the school based off of our sample population. Now we have all students at the school. Since we didn't have multiple grade levels included in the survey, we can't assume this, or we can't gather results from this population. And then our last answer, all fourth grade students in the county in which the school is located. Also no, since only participants in the study were from one school. So since this is smaller and this is a greater sample size, since it's saying all fourth grade students instead of just 40 students, B would be our answer for this question. Looking at our final problem for today, we have the ratio 140 to m is equivalent to the ratio 4 to 28. What is the value of m? So once again, ratios, as I did in a problem earlier, I think it was this one, ratios, conversion factors, however you want to call it. For here, it is conversion factors, but for here, it's a ratio. The mathematics behind it really does work the same though. I'm going to write each of them out as a ratio or a fraction. It's equivalent to 4 over 28. So I'm going to set these equal to each other, and we're simply going to simplify. So we have, or cross multiply. So if you don't know how to cross multiply, you multiply these two, and then you multiply these two. So we have 140 times 28 is equal to 4 times m, and we get 140 times 28. It's going to give us 3,920, and that's going to be equal to 4m. So our m value after dividing by 4 is going to be 980. So that gives us our value right there. And that's also an input question of medium difficulty. Not too hard. Just a quick wrap up for today's session. Make sure you know mean, median, and mode, how to find each one, what each one means. And also know that sample size and applicability of survey results vary according to how the procedure is done. And finally, just know your ratios and conversion factors and be comfortable flipping each around or manipulating each to simplify your answer if it is dealing with conversions, or if it's simply just solving for a variable, setting each equivalent to each other. For instance, I can't set 140 over m equal to 28 over 4. It has to be 140 over m, so this is not going to be equal to 4 over 28. This isn't mathematically correct. I would have to set m over 140 equal to 28 over 4. I would have to flip both. I can't flip one and not the other. So simple rules like that for today, and I hope this helped. And please join me on the next day of the series to further level up and master the SAT math.